What's up, folks? How's it going? It's been a while since my last video. I've been doing a lot of projects here and really stretching the machine out as far as I can and trying to work out as many of the bugs as possible. So in this episode, I'm gonna kind of give a little brief overview of a couple of the projects that I did and try to cover some of the new settings and the new way that I'm running the machine. You may notice my little pal here. Besides woodworking, one of my other passions is falconry, which is hunting with the bird of prey. This is my female Harris hawk, Slammer, and she likes to play with her hood strings, as you can see. So she gets a little upset whenever she can't get a hold of it. One of my recent projects has to do with that. So here's some of the stuff that I've done. I've done a lot more than this, but this is a pretty good overall of some of the stuff that I've done. This right here is what I'm calling a falconry tray. Your basis of falconry is based on making your own equipment. So this I made is like a little tray. So it's got all little pockets and whatever for supplies as far as pencils and knives and little pieces of stuff for the leather to make all the gear that we use with the birds. So this is what one of my I just finished this up today. It's still a little tiny bit tacky. I made of course, since I'm a Marine, I'm gonna be making some EGAs. Some of this stuff I'm actually calling a miscut because there's some details that I just don't like in it and some settings that I have changed since then to improve things, and that's some of the stuff that I'm going to cover with you here. The first thing that we're going to discuss is my new settings on the dip switches. The dip switches are something that some people, you know, are a little bit intimidated to switch and to mess with. So I'm going to show you what I did and how I made the change that has worked absolutely amazing for me. So let's go under and I'm going to show you where my dip switches are set to, and then explain a little bit about what those settings do. All right, so this is my setup. This is where my control box and stuff is, which is all underneath my my work table up top. And as you can see here, so we've got number 1 off, number 2 on, number 3 on, 4 off, 5 off, and 6 off. These first 3 switches control how many pulses it's going to take per step. So with this setting right here is taking 200 pulses per step. And then the last 3 have to do with the power that is sent to your motors for your CNC machine, your actual stepper motors. And the way this is set up right here, this is putting 3.5 to the stepper motors, 200 pulses per step. And trust me, the 200 pulses per step has plenty of resolution for just about any of your jobs that you're gonna do. And the last setting with 3.5, that is going to be plenty of power, and it's not going to overdo your stepper motors, because most stepper motors are ran overpowered anyways, and they're designed to take that 10% or so over. And these are 3 amp motors, so this being 3.5 amp, that would be the absolute max. So that's the motor being revved out and used to its max. It'll push 3.5. The vast majority of the time, whenever you're doing your cutting, the likelihood that you're going to be running the motors at the full 3.5 at any given time on a sustained amount of time is going to be pretty rare. And even then, these motors are designed mostly to be ran about 10% over. So it's going to be okay. Your motors are going to be fine. And the general rule of thumb is if you can put your hand on the motor and you can hold on to it and it's warm, but it's not so hot that you have to jerk your hand away, then your motors are just fine. They're running optimal temperature and you're not gonna have any issues. All right guys, so on this, I wanted to show you, I didn't want to get just a laptop for this because I wanted a bigger screen to be able to see everything with, you know, a little bit easier, and to be able to operate my machine and have like a dedicated computer that is just for operating this machine. So this is the package that I came up with. This monitor was only 75 bucks on Amazon. So I mean, you can't get much better than that. And I think it's a 21 or 22 inch or something like that. And then there's these things that they're called micro or mini PCs. So this, for us, you know, 10, 15 years ago, 20 years ago, you'd have your big tower that was your computer. Now that's all into something this size right here. So this is a complete computer, came with Windows 10, Windows 10 Pro actually, and everything already in it, brand new. It was $175, I believe. And then all you got to do is you need a keyboard. So this keyboard I've got it, you know, in plastic here, for obvious reasons. This is a wireless keyboard, but I have it plugged in for right now. And whenever I do need it or I want it to be remote, I can take this and I can go anywhere around the machine. I can control any of the movements remotely if I wanted to. But I didn't want a mouse in here that's obviously going to get dirty, it's going to get clogged or whatever, so I didn't want any of that. So this has actually this has the trackpad and mouse built into the keyboard, so it's all one unit, and I can keep it under plastic like this, and it's all good, protected, nothing's getting messed up, nothing's going to get so clogged with dirt that it's not going to operate anymore. So for my setup here, this is just the basic of the basic. This has only Mach 3 on it. There's no other program on here besides Windows. I don't run anything on this computer. This is purely dedicated to this machine. Now, as such, I don't have a screen capture program on here. Hopefully you'll be able to see them through the video of just capturing the screen here with the camera. If there's any details that you can't see that you need a question later on, no problem, just hit me up on the comments and I'll do my best to answer them. So one of the problems that a lot of people have is losing steps. If you start at 0 and you cut a project, and in your programming of your project you have the command for it to return back to the 0 position after the cut, your cutting tool isn't in the position you started out with, or your carvings are messed up, a little bit off, not even like but a micro-millimeter or something, you can still tell usually. When that happens, you're losing steps. And the number one reason why you're losing those steps is due to not having enough power to your motor to provide enough torque to keep those motors in position and not skipping. And then the rapid movement for it to go back and forth, or if it's cutting some fancy circle or whatever it is, it needs that power, it needs that torque to keep it in place so that the momentum of the weight of the actual spindle and your whole entire Z-axis, it has to be able to have enough power to hold that sucker in place. So one of the very first things that you need to do in order to increase your torque is you need to up the power. So that's what those last 3 dip switches were doing. It's providing more power to the motors. And then your steps your step settings, the first 3 switches on the dip switches, if you go, the higher you go in steps, the less torque you're gonna have. Mine are now set to 400, and that is plenty of pulses per step to give you great results on whatever cuts that you're doing. So with the combination of it being 400 pulses per step and 3.5 amps going to the motors, this machine runs extremely smooth, extremely quiet, and it cuts phenomenally. Now, when you make your adjustments to your dip switches, you're gonna have to come in here and you're gonna have to also reconfigure your motors. So again, I hope that you can see this. Down here, it's about 100 steps per. I have it at 5,000 velocity and 3,000 acceleration. This is for all of them, except for, this is X and Y. Right, and then the Z is the only one that's different. The Z is 100 as well, because it's the same type of motor. It's a NEMA 23 motor. And then velocity of 600, acceleration of 600. Because you want the head, you don't need the head jerking up and down and messing up your settings as far as your tramming settings and all that kind of stuff. It just needs to glide up and down, and it will compensate. So like if it takes a little bit longer for your cutter to come out of a cut and into the next one, or ramp up or ramp down, the machine will compensate for that as far as the X and Y movements. It's not going to just take off and think that the Z-axis is the same settings as far as velocity and acceleration as the X and the Y is. It's going to compensate. It's going to slow it down a little bit for your ramps that you want and your plunges, and you'll be good to go. But I promise you, if you have this a little bit lower here on your velocity and your acceleration for your Z-axis, you will have good results. Now, if you don't know how to calibrate, those are good numbers you can plug in, right? The 100, and then you can go to settings here. The easiest way is to just put a little pencil mark on this aluminum. So if you just come over here on the side, you can see one of my old marks. And it's real simple. You just use pencil, rubs right away. Just take your pencil, put a mark right here. So that's your start mark. Come back over here. Now we're gonna go for steps per unit, X-axis, and then we're going to do 500. And once we do that, that's gonna move. And then very simply, you just measure from right at the same spot right here where you made your line to over here, and you can see it's exactly 500 millimeters. So for me, there's going to be no change, there's going to be no adjustment. So this is what's going to pop up after you do that. And if you put in 500 to move and you only moved 450, you plug in your 450 right here, and it's going to give you, say I moved 500, and it's going to give you your exact settings of what your steps per unit are. And you do this, if you do this one time with each axis, you're going to come up with a good number, but you need to do it stretched out more and more. So if you start with 500, it'd be good to get that setting right here. Click yes. And then do it again, but do it for 1,000. Because you might drop 1 or 2 millimeters over that distance. And then it might need to fine tune it. As far as settings, I believe that is pretty much everything that I've really changed. And this has been a lot of trial and error, so there's been a lot more firewood that I've made than I have made finished projects. Changes that I've made to the machine. Well, for the Z-axis, I have upgraded this motor. This is the NEMA 23 motor, but it is the next one up from the one that comes with the unit already. That I upgraded. It provides more torque than the original ones that came with it. And I wanted that extra amount of torque to be able to hold the weight of this up and down and keep it stable for the cuts that it needs. I do plan on making another bracket. I'm probably going to have a bracket that's going to be about this big that I'm going to make using my 3D printer, and it'll just grab a hold of more of this spindle and keep it a little bit more stable. All right, so these thrust bearings, you know, they work well, but these things are going to wear faster than any of your other bearings probably. You know, it's an open bearing. It's not a sealed bearing. There really isn't any lubrication to speak of, and then any lubrication that you add is just going to attract dust like a magnet. So these aren't going to last that long. And as a matter of fact, my X-axis one did not last. So I came up with this little design that I made on my 3D printer, and it uses a 608ZZ skateboard bearing. It has an 8mm diameter inside, which is the same as our lead screws, and it basically holds the bearing in place here, and then you apply the tension for your X-axis tension, the tingle tensioning, and then you lock your collar on, and the collar rides on the inside of the bearing while this plastic joint holds on to the outside of the bearing. And this thing has worked phenomenally well and has reduced the noise by a lot. And so far, I've not seen any issues. I've not seen any signs of fault. It runs great. And the noise has been reduced on the whole machine. The carriage here, this gantry, the X gantry. So I will be using that same setup on the Y-axis thrust bearings once those go, or once they show that they are going to be going. So that, I believe, is about it as far as the recent updates, the settings, and some of the cuts that I've done, some of the tools that I've been using. This is a really good tool. It's an up-down cutter. It's a 1/4 inch, it's flat, and this thing cuts amazingly well. This is what's on here right now. But I love this bit, and I think it was like 20 bucks, and it's on Amazon. This has been a really good set, or a really good blade. But for right now, Game 4 of the World Series is on. And if you are a baseball fan, this is the 6th inning, I believe, and Dodgers are back on top. So I am gonna get this annoyed girl back to her enclosure because she's hungry, and I am going to wrap this video up. I'm glad you guys came back. Hope this helps for some of the settings and some of the issues that some people have been having as far as the skipping of the steps, and maybe the whole deal, if you can find the same deal as far as the setup as far as the computer. This was a steal in my mind, because for like $250 something, I think it was like $250 or $260 it came out to be. This thing has its own dedicated computer that I don't even have it hooked up to the internet, even though I do have the Wi-Fi out here. I don't have it hooked up to the internet. It's not going to be plagued with updates from Windows or whatever. If I get an update from about Mach 3, you usually get an email, and I can just put that on a little SD card, and I can plug it in over here and load it on here if I need to. The switchover for Mach 3 was real easy. Just copy all the files for the Mach 3 program on the computer I was using to begin with, download the demo mode onto this computer, and then take all those files out of the Mach 3 file and dump all your files in there from your other computer, and it just works. It has all your settings, has everything, and it works right from the get-go. I had no problem. So I didn't need to contact ArtSoft or anything to get any help with the change. Nothing. So pretty sure that's it. If there's any questions, comments, or concerns that you might have, just go ahead and put those in the comments, and I will respond like I always try to do. I plan on doing, I've already been working on some videos of some of the projects that I've been doing, so I'm not showing too much of actual projects in this video, but that's because I already have videos that I've been producing of projects as I'm doing them, as I'm making those projects. So you'll see it all in one shot, whereas those projects might have taken 2 weeks, or the video might have taken 2 weeks. Either way, I do have other episodes coming out with projects in the future, things that I'm working on right now, and hopefully I'll be able to help you out with how to get started on some projects that you might not know how to do yet. Also, again, if you want to get started on Fusion 360, check out Lars, and the link is below. He is an absolute expert on Fusion 360, and if he doesn't have a question already answered for you, just send him an email, and he's very responsive, and he's very good at getting back to people and helping them out. He's a really good guy. So if you want to get into Fusion 360 and you want to start producing or making your own projects, your own designs from scratch, instead of just buying STLs from other people and buying other people's projects and reproducing them, that's the best way to do it. It's a free program, and it is a powerful program. So, all right, I'm gonna get back to the game, and I will see you guys next time. See you later. Say bye, Slammer.